Math 3, Unit 1, Section 6, Part B. So we're just going to continue doing piecewise functions. If you notice here, how many different pieces are on this graph? 3. So again, I'm going to label these as 1, 2, and 3. The next thing that we should do is, I can make this a little smaller, we need to highlight on our graph. And so we can see here we're going to need to have a line highlighted at 0, and then one at 2, and then another one at 5. Also, sometimes, so that you don't get mixed up, it's a good idea to mark which equation is going to be in each of the pieces. So x is less than or equal to 0. That is equation 1. So over here, I'm going to write equation 1. From 0 to 2 is equation 2. And then from 2 to 5 is equation 3. And then we shouldn't have anything graphed after 5. So far, so good? All right, so let's go ahead and start with equation 1. So I like to kind of just like label my work. And so for equation 1, I like to write it like this: y equals 1/2 absolute value of x plus 2. What type of function is that? Very good, linear absolute value. Okay, and so with linear absolute value, is there a vertex? Yes. And what is my vertex here? Very good. -2, 0 is correct. So let's go ahead and plot that point. We go -2 up 0. And I'm going to mark this as with a V, because sometimes, I'm just going to show you guys that, when we have so many graphs and we're doing so many points and different things, it's important to remember that your vertex is symmetrical. It helps you to graph it better. And so it's a great idea to mark that just so you don't forget as you're going through all this. Okay, can I use slope with linear absolute value? Yes, and so what is my slope? Good, 1/2. So we could plug in points here, but if you want, you can just use your slope and figure out what's going on. So we're going to go up 1 and then right 2, and we end up at that highlighted line. We need to go up there and look, is this going to be open or closed for this graph? Closed. So we're going to make our closed point there. And then we know this is linear absolute value. So since I have this point, we know that it is what? Symmetrical. And so since this is 2 away from my vertex, from my line of symmetry here, we go 2 on the other side. And then we are just going to draw the graph in the area that is reserved for equation 1. So I'm going to stop there for just 1 minute, and I would love any questions that you have, confusion, why points are where they are. No? That's okay? All right, then let's move on to equation 2. I'm going to use a different color on this one. Yes. Are you sure? Okay. Equation 2. So looking up here, equation 2, we know where it is supposed to be. It's just this little piece right here. And so I'm going to write the equation. Y equals 2 to the x minus 6. Now, what type of graph is this? Very good. This is exponential. Okay. So exponential is the one that's kind of graphed a little differently. And so we want to make a mark starting where? 0, 1. So we have 0, 1. And then this is translated where? Very good. Down 6. So this is translated down 6. So from 0, 1, we're going down 6. Now I just want to make sure, because a lot of you kind of miss this on your quizzes, Notice with the x, there's nothing up there in the exponent with the x. If there was, that's the translations going right and left. Okay, and then everything after this, that's your up and down translation. Also remember that this value right here is also translating your asymptote. And so my asymptote is going to be at what value? -6. This value always gives you your asymptote value. Okay, and so if you want to, we could go down 6, 1, 2, at -6, and make our dotted line there for the asymptote. But remember again, it's only in this little area that we're doing equation 2. Okay, also from our 0, 1 point, we're going down 6, which is really at -5. And would that be an open or closed circle there? Open. And we know because it's on the 0 line, and for equation 2 at 0, there's no equal sign. So there is an open circle here. Okay, what is the other value that's going to make the most sense to find for this graph? 2. Okay, because if I have what's going on here at 2, then I can just draw my exponential function and I'm done. Okay, so we're going to plug 2 into this equation. So 2 to the second power minus 6. 2 to the second power is what? 4. And then 4 minus 6 equals -2. So my point for this one, I plugged in 2 and we found -2. So 2, -2, is that going to be an open or closed circle? Open. And again, if you look back up here, there's no equal sign with the 2, and so that's an open circle. And we know exponential function just kind of shoots up like that, and so we're just connecting those 2 lines right there. All right, are we ready for the last one? Or do we have questions right now? Okay, third function. Okay, so our third function, our equation is y equals x minus 3 squared. What type of graph is that? Good, another quadratic, or actually this is the only one here. Quadratic, and quadratics, what do we know about them? They're a U shape and they have an asymptote. No, they don't have an asymptote. They have a vertex, but they have a line of symmetry. That's what I think you were talking about. Vertex. Okay, what's my vertex? Very good, 3, 0. Okay, hopefully we're getting pretty comfortable with finding our vertexes and our starting points. Okay, Nathaniel getting all this? Okay, 3, 0. So 3 up 0, I can make that point there. And again, because that vertex is not in the middle there, for me, I just want to put a V to remind myself that that's my line of symmetry. Okay? Now, for this equation, what would be a point that I'd want to plug in? Good, I'd want to plug in 5. So we're going to plug in 5, find the other value. So when I do that for 5, we get 5 minus 3 squared. What's 5 minus 3? 2, and then 2 squared is 4. Now, is it going to be open or closed at that point? Good, closed, because there is an equal sign underneath there. So 5 up 1, 2, 3, 4, and we have a closed circle. Now, there is a line of symmetry, but when I go this way to go 2 more across, you see how it's going past that line? And so because this isn't a straight line, because it's curves, we're going to have to plug in this other point to figure out what exactly is happening at this value. So we're going to find another point for this graph, which is 2. Good. And so when we do that, we plug it into our equation. 2 minus 3 squared. 2 minus 3 is -1, and -1 squared is 1. So 2, 1. And is that going to be open or closed? Open. Good. And actually, I think this should have been closed. We're going to go ahead and make this an equal to sign just to make it a function. Okay. All right. So that's that. Do we have, yes?
How do we get the number 5? Is that when you use 5 for x?
Oh, why did I use 5 for x?
No, how did you get 4?
5, so we plugged it into the equation, right? 5 minus 3 is 2.
Okay, thanks. I can get it on.
Okay. All right, are we good here? So now we're going to write out the domain and range. So we can just look at our graph now. Our domain. So going from left to right, what is my smallest value for the domain? Very good. Negative infinity. And as we go along, bless you, there's a closed circle but also an open circle, so we're good, right? We keep going. We get here, closed circle and open circle, so we're good. We keep going, and then we have a closed circle here where it stops, and so this is negative infinity to what? 5. Because remember, it's okay, we're just doing all the x values, right? So this is the x value is 5. And bracket or parenthesis? Bracket, because it actually ends there. It has a solid point. We'd use a parenthesis if it was an open circle. Okay, range. What is my smallest value for the range? Good. It is at negative 5. Would I use a parenthesis or a bracket? Good. Negative 5. This one's an open circle, right? It is exponential, and so normally it would be negative 6. Do you guys agree for this graph? But because it's not going this way further, it's not getting to that negative 6 line, and so we know specifically right here it's only at the negative 5. Okay? Now, if it was one where it didn't have open and closed circles, you're right that it would start at negative 6 where the asymptote is. Okay? Yes? Yes. So this right here, it is a parenthesis. So closed circles are the brackets, open circles are parentheses. Is that what you're asking? Or no?
No, because they look like those are closed.
Oh, yeah, it's actually open. Yeah. And if you look back up at this right here, the first function is the one that has the closed circle, and then the second function is the one that has the open. Okay? All right. So negative 5, and then we go up, and then there's an open circle here, and there's nothing else to fill it in anywhere else. And so what is that value at? Negative 2, right? Because we're just doing our y values. So negative 5 to negative 2. Do we agree? Okay. And then we're going to do a union. And as we go up, there's like, it doesn't start back up again here. And where does it start back up again at? 0. And is that going to be a bracket or a parenthesis? Bracket. Why is it a bracket? It equals that value at 0. There isn't an open circle. Okay, and we go, and do you see how we have this arrow right here? So that means it goes where? To infinity. And because infinity never ends, it's a parenthesis. Okay, any questions there? Yes?
After each blue ring having negative 2 zeros?
Wait, say that again?
After you do, shouldn't we put like negative 2 zeros? And then for other you
You're Normally, that happens a lot of the times. But do you see how there's nothing going on between -2 and 0? There's no line there. So that's why there's nothing there. So it's like you have this part of the graph for the range, and then there's a break, and then it starts back up here. Okay? Is that clear? All right, so now this question says, what is the answer for the function at -4? So this is your x value, and then they're wanting to know what is the y value. Now you could go back up to these equations and figure out which one it goes in and then plug in those values. That is one way to do it. Another way is to look on the graph and see if you could find the answer that way as well. So, f of -4. -4. 1, 2, 3, 4. What is the answer for what's the y value when x is -4? 1. Does everybody get that? So for the f of 2 on our graph, if we go right to, where is the solid point? 1. So that answer is 1. At 3, what is the answer? Good. At 6, what is the answer? No solution. It's not on the graph. Okay, any questions? Okay, we're going to do the next one. Okay, so we're going to label these again. Equation 1, equation 2. Where do I need to highlight? At 1. So on our graph, we're just going to highlight at 1. And this one is a little bit different because one of them is saying that it equals 1 and one of them saying is it's everywhere except for 1. Okay? So on this equation 1, where it equals 1, right here, this is equation 1. Okay? Only that line. But equation 2 is everywhere except for that line. Is that okay? So let's go ahead and graph the equals 1 first. What is that going to be? So for this one, for equation 1, normally that would just be a line, correct? And it's specifically the line y equals 2. So if we were graphing it, we would have a horizontal line there at y equals 2. But this graph is saying, nope, it's only at the value of x equals 1. So what do we do there? We just make a point there. So just that point, and it's closed because it's equal to. All right, any questions? So we just have that point. So normally that line would be at y equals 2, and this actually makes a point at 1, 2. Because x is 1. If we were plugging 1 in here, you couldn't get anything else except for the answer of 2. Okay. Now for our other line. Oh, sorry. Our other equation. What is it? What's it? Yes, thank you. What is our second equation? Very good. It's also linear. Or line, okay? Y equals -3x plus 1. What would be our starting point for this one?
0.
Good. 0, 1. Nothing's in parentheses with the x. 1 is at the end. Okay? So 0, 1, 0, up 1. I'm going to go ahead and make that point. And then, can I use my slope on this? Yes. What is my slope? -3 over 1. So from my starting point, we're going to go down 1, 2, 3, right 1. But at that point, it's going to be a open circle. Okay, we could also go the other direction, and you would just go positive 3 and then left 1 for a negative 1. And then all we do is go ahead and draw our line, but just make sure that it takes a break at that open circle. So it's that whole line except for there's an open circle on that line because it doesn't equal that, but it equals everything else. All right, do we have questions about the graph? Okay, what's my domain? Negative infinity. So going from the left, we have an arrow, so that's negative infinity. Going to the right, I have an open circle, but do I also have a closed circle? So we're good. We keep going. We have an arrow, and it goes all the way to positive infinity. Okay, for the range, it starts at what? Negative infinity. It goes up, and we have an open circle, which means we have to stop there, right? And so what is that value there? Negative 2, and we would use a parenthesis, and then we have a union, and on this one it does start right back up, right? And so we're going to use negative 2 again, and as we keep going up, even though there's like points here and there, it's fine as long as there's not like an open circle without anything, and it goes all the way to what? Positive infinity. Okay, so looking here, f of 1. So again, remember that this is your x value. We're trying to find the y value. So when x is 1, what is the value for y? 2 is correct. It's where the solid point is. Okay, when x is 0, what is the y value? 1. When x is negative 2, what is the value? 7 is correct. Now for me, when I'm at negative 2, I'm not exactly sure. So if you're not sure, what's the best thing to do? Plug it in. So if I were to plug it into my equation here, it's this line. We would have negative 3 times negative 2 plus 1, and we get 6 plus 1, which is 7. So you guys all gave me the correct answer, but there is a way to double check and just go to the correct function. Any questions there? Okay, moving on. Okay, so this says write the piecewise-defined function for the graph below. Okay, so it says for the interval, we're going to start with A here, for the interval negative infinity to 2, or sorry, negative infinity to negative 2. So I'm going to go ahead and highlight here. So if we're looking at our domain from negative infinity to negative 2, what type of function is that? Very good. Linear absolute value is correct. Okay, and then it says B for interval negative 2 to positive infinity, state the type of function that is represented. What is that one? Very good. Quadratic is correct. Okay, C says write the equation for the function on the interval negative infinity to negative 2. Okay, can we do this? I think so. The first thing is because this is linear absolute value, we want to know the vertex, correct? Okay, so what is my vertex? Negative 4, negative 1. Very good. So if we start to write this equation, we would write it as what? Y equals, close, we're going to do A, because we don't know what that is yet, correct? Absolute value, and what's going to go inside the absolute value? Very good, x plus 4, and then what? minus 1. So all we're doing is using our vertex and putting it into the equation. Yes? Because that's where our vertex is. So here's our vertex. It's at negative 1, 2, 3, 4, negative 1. Okay, yes or no? We're good? Okay, so I'm going to stop you there for 1 second. Okay, so we need to find the A value, correct? All right, so you have two options. Option 1 is to take a point, plug it in, but we can't take the vertex, correct? Any other point on the graph. Or T was just saying, could we just figure out what the slope is because it's a line? So could I just figure out what my slope is and put it in for A? What do you think the answer is? Yes, we totally can do that. What do you guys want to do? You guys just want to do the slope? Okay, but if you wanted to find a point and just plug in a point, you could. How many of you would rather just do a point? Because that's what you're used to doing. Okay, one person. How many of you would rather do just the slope because it's easy? Okay, and when is the only time we can do the slope? When it's a straight line. So we can do linear absolute values and a line, and that's it. We can't do slope when we have parabolas, quadratics, exponential functions. Okay, we're going to go ahead and just do the slope for now. So the slope is what? It's, if we go from this point to this one, it's going up 2 and right 2, 2 over 2, which really reduces to be what? 1. Also pay attention, this one is going up, so your slope is positive. If it was facing down, your slope is negative. And so this equation then is just y equals absolute value of x plus 4 minus 1. Could you put a 1 in front here? Yes, you could. Do you need to? No. Will you get it wrong if you put it there? No. Okay. Any questions on that? All right, D. Write the equation of the function on the interval negative 2 to infinity. So now we're doing the function over here. What type of function is that again? Quadratic, which means it has a vertex. What is my vertex? Very good. Negative 1, 2. So if we start to write this equation, we write it as y equals, what comes next? A, or whatever you put, that's fine. Normally we put A, and then it's going to be x what? X plus 1 squared plus 2. Don't forget that quadratics have that squared. Now, can I use slope on this one? No, because it's curves, okay? So we have to choose a point. What looks like a good point to choose? Okay, so I heard the point, what did you say? Negative 1. Negative 1 won't work because that's going to be our vertex, right? You could do negative 2, 1. You could also do 0, 1. What do you guys want? 0, 1. It doesn't matter what you choose, you'll end up with the same answer. Okay, so 0, 1 is what I'm choosing, and I'm going to label this as xy. This way, hopefully, I put the right numbers in for the right things. So looking at this equation, we would plug in 1 equals a parenthesis 0 plus 1 squared plus 2. Zero plus 1 is 1. 1 squared is 1. So I have 1 equals 1a, or just a, plus 2. Very good. Subtract 2. And what does a equal? Okay. Does that make sense? Always check your answers to see if they make sense. Does it make sense that my a value is negative? Is this curving down? Yeah. So if this is curving down, this should be negative. If it isn't, you messed up, which means you probably forgot to like have that be squared or something like that. So always double check. And so now we have our function. Y equals negative parenthesis x plus 1 squared plus 2. And again, could I put a 1 here if I want to? Yeah. Yes, it's just not necessary, but however you do it is fine. Do we have any questions there? Okay. I am not going to do all these right now. I think that you guys know how to do them, so we're just going to do one, okay? What does this one mean? So what they're saying is that above graph, way up here, what do they want you to do with that graph? They want you to translate it what direction? This one, they want you to translate right to. This one, they want you to do what? Very good. Reflect across the y-axis. And then this one, what does that mean? This is absolute value, which means nothing below the x-axis. So anything that is like below the x-axis, you would take the absolute value and it would flip up and go above. So out of these three, which one looks the most difficult that we should probably do? The absolute value. Okay, I completely agree. So, now, you guys will have some questions like this on your test, okay? What is the best way to deal with these? Do you guys know? Figure out where these points are and we put X's on the graph. You guys remember that? We've done this already. Okay, so for instance, we have negative 1, 2, 3, 4, 1. This is negative 4, 1. This point right here is at negative 5, 0. This one right here is at negative 3, 0. This point right here was at negative 1, 2. And then this one, basically, if we wanted to, that's like at a half 0, something like that. So I would just have some points and I would mark them with X's on my graph. So I'm going to move this up and then I'm going to be talking about these points here, okay? So I'm going to put an X at negative 3, 0, and then one at negative 5, 0, and at negative 4, negative 1. And then, let's see here, I'm going to put one at negative 1 up 2. And I didn't mark the other one, but there's one there at 0, 1, and then it's at like a half 0. So then I just start drawing the graph going from left to right. If we were translating it right and left or up and down, I would go to each one of these points and I would go right to, right to, and move all those points first. For the absolute value, we only have to worry about things that are supposed to be drawn below the x-axis. So if you look at this graph, do you see how this is all fine? But at this point right here where it's going below the x-axis, this part will need to flip up. Yeah. Yes, thank you. Negative 4, negative 1. Okay, good job. You can have a candy later. Okay, so I'm going to start from the left, and this all is fine because it's above the x-axis. It's not negative. But this, when it's below the x-axis, this needs to flip up. So see how this is 1 away from the x-axis? It's going to be 1 away up here. So what happens is it goes up there, and it goes down here. So it's reflecting over. When you're taking the absolute value, it's reflecting over. So if you look here, this part that was below just reflected up and it made that V that I drew. Does that make sense? Okay, everything else though kind of stays the same until we get to this point right here. So if you're looking as you're drawing, this still goes up like this, and then it starts curving, and it curves, and it goes to here. And then what do you think is going to happen at this point? So if you think about the reflection, if it's reflecting, it's like this is going to be up here, so it's just going to shoot out going that direction now. And so that would be your absolute value. Okay, do you think we need to do any others, or you think we're okay with the others with reflecting across and translating? We're good? Okay. Last problem. I think we've got this. Anybody have a loud voice and want to read? Thank you.
Shipping company has a flat fee of $4 per package for packages up to 2 pounds plus an additional charge of $3 per pound or any part of that pound. For example, a 1 pound package costs $4 and a 1 pound package would cost $7. If A, the X represents the total cost in dollars as a function of X, where X is weight of the package in pounds and 0 is less than X, less than or equal to 6.
Yeah, that's good. So we're going to sketch the graph. Okay, so we want to make sure that we understand everything, which sounds like we're not quite sure. Okay, so a shipping company has a flat fee of $4 per packages for all packages up to 2 pounds. So for instance, if you were to go to the post office and say, I need to mail this box of cookies to my friend, I don't know, and let's say it weighs 2 pounds, they will charge you a flat fee of $4. Okay? So could it weigh less than 2 pounds? And you would still pay $4. It could weigh 1 pound. You would still pay $4 for this specific package. Okay? So if we are just graphing that piece right there, okay, first of all, we need to label these. Okay, so right here, title the axes. What do you think is going to be labeled? So we have money and we have, what's the other thing? Pounds. Okay, or costs in pounds. What's going to go where? What do you think? Very good. Your cost is what is going on the y-axis, and your weight or pounds is what is going on the x-axis. And so it's important to always label those. And so we know that from $0 to $2, the cost is how much? $4, which makes a straight line. Do you guys agree? Because it's not going to be more than $4. It's not going to be less than $4. Anything between $0 and $2 is, or sorry, 0 and 2 pounds is $4. Okay, now, are you going to mail something that weighs nothing? No. So if it weighs 0 pounds, you're not going to pay anything, correct? Because you're not mailing anything. And so that's why I'm putting an open circle there, because I'm not going to mail something that is nothing. I'm not just going to go to the post office and say, I don't want to mail anything, but here's $4 because I know it's a flat rate, okay? So then we mail anything to 2 pounds, and at 2 pounds, it's still going to cost me that $4. Do you guys agree? So that's a closed circle, and we're going to draw this straight line. Okay. So we have this first part done. The other thing that, and I kind of feel like sometimes I talk out of order, but it's saying that it's only until you get to a weight of 6 pounds. Okay, so anything can go by this flat rate from 0 to 6 pounds. So I would highlight at the 6 anytime they give you that domain restriction. Highlight it, because as you're doing some of these graphs, you're going to want to keep going, because there's going to be a pattern and you're like, oh, I get it, and I go and go and go, and then you graph something that's not supposed to be there. Okay, so it's always a good idea to highlight your restrictions. Okay, so then it says plus an additional $3 per pound for any part of that pound. So if it weighed 2.1 pounds, you have to pay how much money? $7. Does that make sense? So at 2 pounds, it's $4, but anything past 2 pounds, up to 3 pounds is going to be $3 more. So we're going to go up to 7. And is it going to be an open or closed circle here? Open here, because at 2 pounds, I really am paying how much? $4. But between 2 to 3 pounds, it's going to be 7 because we added that 3. And at this point right here, is this going to be open or closed? On the 3 side, will this be open or closed here? Closed. So at 3 pounds, at exactly 3 pounds, I'm still only going to pay $7. Okay, what's going to happen when it goes past, a little bit past 3 pounds? It's going to go $3 more, right? So any little bit past 3 pounds, we're going to have to add $3 more, which will take me up to what? $10. And is that going to be an open or closed circle? Open. And so then we have anything between 3 and 4 pounds is going to cost $10. And then at this point, is it going to be open or closed? Closed. So at 4 pounds, it still costs $10. And then what happens when we get to past 4? 13, open or closed? Open. And all the way here, it's going to cost the same amount. And at 5, is it going to be open or closed circle at that 5 pound mark? Close. And then what happens when we get past 5? It's going to cost how much? 16, open or closed circle? Open. And then all the way, and at 6 pounds, is there an equal to sign here? So it can equal 6 pounds, and we would pay that $16. But anything above that, they will not take. They will not mail it for you at that rate. It probably goes up much higher. Okay. Is anybody confused by this? All right. What is the domain and range of this function a of x? Okay. So my domain is what? 0 in parentheses all the way to 6, because as you go along, even though we have an open circle, we also have a closed. So 0 to 6, and it's a bracket. If we were writing this in interval notation, it would be 0 is less than x is less than or equal to 6. The range is from, the smallest range is 4, and even though there's an open circle, there are also other points that are not open. So it's a bracket for 4, and it goes all the way up to 16. And that would look like 4 is less than or equal to y is less than or equal to 16. For time's sake here real quick, they want us to write the piecewise function for this. How do you write a straight line? It normally would be, this would be like y equals 4. Do you guys agree? So this would be 4 if, and then you would write the domain of that value. 0 is less than x is less than or equal to 2. Okay, that's like the y equals 4. Okay, and we're going to end up out here, it would be your a of x. Okay, the next line is at what? 7 if 2 is less than x is less than or equal to 3. Okay, so remember that's a straight line, and it's just between 2 and 3. The next number is going to be what? 10 if 3 is less than x is less than or equal to 4. The next one is 13 if 4 is less than x is less than or equal to 5. And then the last one would be 16 if 5 is less than x is less than or equal to 6.